So modules are just a chunk of code. It's a code library. Somebody else has written some code, and we are just going to include it in our program. Instead of us trying to figure something out from scratch, we're going to go to a reliable source, use theirs, and carry on. Now remember, you want to make sure it's reliable. Just because somebody wrote some code and slapped it on the internet, how do you know it's really correct? Okay? So for us, when we're using Python, any standard library where I don't have to go and grab the code myself, okay, like the actual source code, I can just reference it with an import statement. So Python has already brought that library of code into its code base. We will assume that that's reliable, okay? If the Python organization has vetted the code and included it as part of Python, then we will assume that it's correct. It's not always true. Every once in a while, they also have bugs, okay? And then they need to fix them, but we'll just accept it. So here's an example of doing it in Python. There's a reserved word called import, and they have this special library called math that has a whole bunch of math kind of stuff. Kind of like your scientific calculator, all those extra buttons that are added to the scientific calculator that aren't there on a normal one, they're included in the math library. So we already learned that Python can do add, subtract, multiply, divide, exponents. So it does basic math built right in. But if you need extra math, then you would include this library. Don't be including the library if you're not going to use it. Why would you not want to include the library if you're not going to use it? It's a waste of space. By doing this, I am bringing in a whole bunch of Python code, and it's being added into my code base. So instead of my program being nice and small, it's actually huge now. Well, if I never use it, why did I bring all that stuff in? In our modern computers, the programs we're running, it probably doesn't matter. But if you're running the code base for like Amazon, and you want to make sure that when someone brings up their account, it shows up within a split millisecond, if you have a whole bunch of leftover code that's floating around doing nothing, that's a complete waste of space and processing time. So we don't want to include it. In the old days of computers, 50s, 60s, 70s, space was really, really expensive, like super expensive, okay? Like tens of thousands of dollars for RAM. So you wouldn't be wasting space because you just didn't have it. So here's an example program. So this is just a Python program. It's got our usual document string at the top. It's got this funny thing at the bottom, which we will eventually get to, but we're not quite there yet. So this is our main function. And inside the main function, it tells you what we want to do. We're going to calculate the area of a circle, and the radius is 15 millimeters, okay? So we're just going to print out if a circle has a radius of 15 millimeters, then the area is, and I have a little holder spot here, this is where we would have to type the code, okay? So formula for area of a circle is? Pi r squared. Here we go, area of a circle. Remember, this is math class, so I am going to say equal here, okay? Area is equal to pi r squared. Now remember, it's squared. We have to remember in Python, we can do exponents, but we have to use 2 stars, right? Okay, we don't use that funny hat thing because we found out that was really bad. So we could go back to here, and we could just replace this with our formula, okay? So what's the value of pi that we use in math class? 3.14. So we could go 3.14, and then we multiply by the radius, which in our case was 15, and then we do 15 squared. So remember, it's star star, and it's 2. Okay? So we've done stuff like this before. That should make perfectly good sense. if I do ls, there's my program right there, and I can run my program. And that seems reasonable, right? 706. Let's go back here. And why did it not? Let's try this. Google should give us a, there we go. If we type in 15, so that's reasonable, right? 706.85, 706.5, so it's close. Okay, we're good to go. But it's not like perfect, right? So in math class, we just normally put 3.14, right? But I don't really want to write that every time. And it's not really 3.14. Like it's 3.14159. I'm going to mess it up. Like if I try to remember too many decimal points, I'm going to mess it up. So it turns out in that Python math library, they have pi. So we could use that. So if we go back, remember this is how we import something. So I'm just going to grab this. And it turns out to import it, we normally put it right here. Okay, so after our initial doc string, but before our main. So if you just put that in, you'll notice import turns into a reserved word. So that's good. And we are going to import the math library. Okay, and when we hover over, it even gives us a little like helper thing. This module provides access to the mathematical functions, defined by C. Remember when we talked about Python? It turns out Python was actually written in C. So Python is using, when you say import math, it's actually running some C code, which is kind of interesting. Okay, so that's nice. And here, instead of writing 3.14, what you can do is you then type in the library name. So for us here, it's math, okay? And notice math shows up. Because I put import here, it shows up in IntelliSense and it knows that it's a module, okay? So math, and then you put a dot, okay? So there's many different things in the math library, pi, sine, cosine, tangent, all kinds of different things. So to specify which one you want, you put a dot, and look, here's the whole list of them. Okay, so these are all the things that are in the math library. Okay, so that's kind of useful, and what we want is this thing right here, pi. So that's how you get math.py to actually show up. And if I run my program again, oh, look, that's way better now, okay? If you look back what I had last time, okay, 0.5, but when I went here, that's not what Google said the answer was. They said it was 0.85. Well, now it is 0.85. So be a good lazy programmer. Don't try to remember 3.14. Just use the math library and it will help you out.